Okay, Cloud Gurus, quick recap. Apps come from ideas and requirements. We start sketching things out to decide what we need, and then we do some coding. And up to this point, it's pretty normal stuff. Once we're done with the coding though, then we build some Docker images, and we looked at a dead simple example where we had a front-end web tier and a back-end database. And each one of those, so the front-end and the back-end, had its own Docker image. Now, we'll be showing you how to get code into Docker images later in the course. But once we've got all of that, then it's time for the Kubernetes stuff. In the sample app, we said this here is basically the architecture. Then we map each of those components onto Kubernetes objects and write it all up in a declarative YAML file. So for the load balancer at the front here, we map that onto a Kubernetes load balancer service, which we said does all the legwork in the background to spin up a cloud-based load balancer that'll talk to the internet and then balance traffic over the components of the app behind it. Now there's magic behind the scenes that we've not covered yet, but it uses labels when it's deciding which bits of the app to send requests to. Anyway, right, the core code of the web component is in a pod that will manage through a Kubernetes deployment object. And we said those are great for scaling up and down and doing updates. We've also got some persistent storage in the mix, mapped onto a persistent volume claim object. And we pretty much did the same for the MySQL backend. So we ended up with a couple of YAML files. Now, you can put them all in one if you want, but the point is, we described our application requirements in Kubernetes YAML. So this maps our requirements onto features in Kubernetes, and then the YAML, honestly, it serves an extra purpose as a pretty classy piece of documentation as well. Anyway, look, to then get it on the cluster, we use the kubectl command line utility to post the YAML file to the API server where it gets persisted to etcd and instantiated on the cluster. And that is the big picture. But big pictures are not why we're here. We're here for the detail. So let's turn the dial up now and we'll get cracking with Kubernetes networking.